Today is we are going to talk about what happens when these radioactive nuclei break down.
There's Facebook, there's Italy trip, Italian,
Alright, so the process, and you guys told me this earlier when we were talking about the breakdown and the decay of a nucleus. You said that a new element can be formed. That process is called transmutation. Okay? It's the changing of one element to another. So you will need a periodic table for some of what we're going to do. So when we are analyzing the transmutation of elements, what we typically do is we write the symbol of the element. What is this? Uranium. We write the atomic mass at the top left. We write the atomic number at the bottom left. And that will allow us to understand how this element might change as it decays. So if we take uranium-238, now often when we talk about these elements, we're going to be talking about a variety of isotopes of different elements. So when I say uranium-238, I'm referring to uranium that has an atomic mass of 238. And uranium-238 will often decay by, again, so it is an unstable nucleus, okay? Uranium-238, okay? And when it decays, it does so by releasing, what do we call this?
particle.
An alpha particle, okay? It's basically a helium nucleus. An alpha particle has an atomic number of 2 because it has 2 protons. It has an atomic mass of 4 because it also has 2 neutrons, giving an atomic mass of 4. So when it releases that, what's left of this original nucleus? If it lost 4 from its atomic mass changes to 234. If it lost 2 from its atomic number changes to 90. Is this uranium anymore? No, because it has a different atomic number. It has a different number of protons in the nucleus. Therefore, it's no longer uranium. It's thorium. So when uranium-238 goes through an alpha decay, it loses an alpha particle. And what you're left with is thorium-234. It also releases some energy in the process.
What's that plus sign for?
Because what's left after is a helium is emitted, and that helium nucleus, that alpha particle, and plus what's left over is the thorium. Nope.
Helium plus.
Because uranium, when it breaks down, releases an alpha particle plus a thorium nucleus. Now, beta decay works differently. So a thorium nucleus, thorium-234, can release a beta particle. This is called beta decay. What do you remember from beta decay? Anyone remember what a beta particle is? Remember we said, how can this be released from the nucleus? This doesn't make sense. Addis? An electron. So what do we know about the mass of an electron?
0.
It's 0. Okay? And remember, when this electron is lost, okay, how is an electron coming out of the nucleus? You're getting close. A neutron releases an electron and becomes
A
a proton. Okay? So the atomic number goes up 1 because a neutron was converted into a proton. Okay? So the atomic mass, does it change? No, but the atomic number does. Okay? It goes up 1 because a neutron was converted into a proton. So after beta decay, we end up again with a new element. What is the name of this element?
Protactinium.
Protacticum. Right? Proactinum.
Prolactinum, yeah.
Proactinum.
Protactinum sounds pretty cool though.
So again, if we look at this,
Protactinum.
here is a carbon-14 nucleus. What kind of decay is it going through?
Beta.
Alpha or beta?
Beta.
Beta decay, because it's losing what? An electron. So originally, this carbon-14 had 6 protons, which are red, and 8 neutrons, which are green. It loses an electron, and what happens to this neutron?
It becomes a proton.
Becomes a proton. So now we have 7 protons and 7 neutrons. What does that do to its atomic number?
Oh, it's atomic number, like it's atomic mass.
Atomic number.
Atomic number. Raise it.
It goes up by
Yeah, it goes up by 1.
1. And is it carbon anymore?
No.
No, because carbon has 6 protons. It's nitrogen that has 7 protons. So this carbon-14 nucleus has emitted a beta particle and it is